From way back in Calc 1, we presented the idea of the chain rule for composite functions. And we set it in the form f of g of t, where y equals f of x and x equals g of t. And we set this up, we said, hey, to do this, if I want dy dt, in other words, the derivative of all of this with respect to t, that this is actually equal to dy dx, because remember x is now a function of g, or a function of t, times dx dt. And this was the chain rule from back in Calc 1. Well, we need to take that exact same idea and expand it to the idea of functions of two variables. So let's suppose that I have z equals f of x, y. So now we have a function of two variables. And x and y are both functions of t, differentiable functions of t. So z is in a differentiable function of t, and what I want to find is dz dt. So that's going to be equal to dz dx times, oops, I need to make a change here on notation. Sorry, I just went brain dead for a minute. This is going to be equal to the partial of z with respect to x times the partial derivative of x with respect to t. Now this piece by itself is very much like we did back here in Calc 1. But because I have two variables, I need to take into account the other variable, y, which is also a function of t. So I need to add this to the partial of z with respect to y times the partial of y with respect to t. So this symbol here is for the partial derivative, and really what we're doing, I guess you can condense this down to say essentially we're doing what we did back in Calc 1, but Calc 1 really only had one variable. This x was a function of t. Now I have both x and y that are a function of t's. So I'm going to take one application and add it to the other application to account for both variables. Now this idea is really essentially the pattern, the process that we're going to follow to apply the chain rules with partial derivatives.